So welcome. Before we get started, I always like to ask, have you done an interview with interviewing.io before?
Yes, I have.
Yeah? Okay, perfect. So you should know your way kind of around the system. It's sort of the same. And then just to confirm, this is for a system design interview. Is that correct? Awesome. So how I generally like to run these, we spend about 45, 50 minutes actually doing the interview. Then I like to leave at least 10 minutes at the end. You can ask me any questions kind of about the interview, if you had any questions about whatever the problem is we went through. And then that also gives me a chance to give you a little bit of feedback live. That way you can do any follow-ups. If there's anything you want to clarify, I still do the write-up at the end, of course, anyways, but like just give you a chance to ask me anything just in case.
Okay.
Does that all sound good? Awesome. So we're going to start with a pretty basic prompt, which is your team owns a bookstore, or maybe better is your team's been hired by a bookstore. They're brick and mortar, and they've decided that they want to open an online business, and so they basically need to build out an entire backend API for clients to be able to retrieve information about their bookstore and what they have in inventory and all that sort of fun stuff.
Okay. I'm sorry, wait, did you say low-level design or system design?
System design.
Should we swap to the whiteboard or? Okay.
Yeah.
Let me just copy this and then paste it in. Okay, sorry, I think I cut you off.
No, that's basically it.
Okay. So yeah, I'd like to go over the functional and non-functional requirements. So from what I gather, I think this is probably going to be like pretty straightforward. I would say so if we go over like the functional and non-functional requirements, I think we probably want to be able to get book information. We probably want to be able to write book information as well. And we probably need some kind of way to search for books by like the author name or title name. Does that kind of sound good for the functional requirements?
Yeah. Sounds good to me.
Okay. So if we go into the non-functional requirements, I would say we probably want to have like low latency, high availability, and we probably want to have like freshness within a few seconds. So say we write a book, we probably want this to be like new real-time updates. So I think that should be good for the non-functional requirements. Is there anything you would probably add?
Well, talk to me a little bit about why low latency and why high availability.
So I would say low latency, meaning like if we search for a book, we want it to be within like a few milliseconds that we get a result.
Awesome. And why high availability? Like, why do we think that's important?
So say we have like high QPS or like high traffic, like we want to be able to give some result back.
Okay. And when we're thinking of like traffic and a lot of potential users, what are you thinking in terms of scale for what we're looking at?
Yes, I mean, I would say we probably want to design this for a higher scale because that's a more interesting question. I think if we consider like a normal library, like even in big cities, the scale is not going to be like that big. But say maybe this is like Barnes & Noble or something like that is what I'm thinking.
Yeah. So if we are looking at something like Barnes & Noble, what scale are we looking at?
I would say it's going to be a pretty big scale, like maybe millions of reads, an hour or so. And maybe we have like about like 1 to 10 million books. Does that sound good to you?
Yeah, sounds good to me.
Okay. So I guess those two paths we can go from now is like, do we want to get into the high level design, or do you want to go over like the API and write that out as well?
Let's start with the high level design, and then we can drop into the API level.
Okay, sounds good. So we'll just have our client, which is going to be our front-end application. And this could be like a mobile app or like a browser or anything like that. And then we want to hit some kind of load balancer. And it's going to be responsible for like authentication, rate limiting, and whatnot as well. So the kind of path that I'm thinking is like, we're probably going to have pretty high read traffic and not very high write traffic. So I think it's important to separate our read and write services to be two different services. That way they can scale independently. So we can have like add book, and we can have get book. So to satisfy our low latency on search requirement, it's going to be beneficial to have something like Elasticsearch or TypeSense, where essentially we're loading the books into memory. But for now, let's just go over like the build basic path. It kind of brings into the question, what kind of database do we want to use? And I think if we consider like Cassandra or Bigtable, like we can have, well, if we think about our access patterns, like we can probably have two separate databases. So like we can have one for like the catalog database and one for like our inventory. And then obviously have our search. I think for now, we can just keep it simple and go with like Postgres. And maybe we come back and like touch on the database here in a second.
Yeah, sounds good to me.
So let me add some to-dos. I have some things that I want to touch on. So I would say probably like Elasticsearch. And then probably splitting our database paths. Before I get into these, is there anything that you think I'm missing or that you wanted to go deeper on?
I think let's start here and see where we get to.
Okay. So I think we can probably go with Elasticsearch first. So what Elasticsearch is, it's essentially going to load all of our inventory data into RAM and let us do like very quick searches. But then the question becomes like, when we write to the database, how do we know how to put it into Elasticsearch? And we can use change data capture for that. And then when we get a book, we want to get it from Elasticsearch. And let me just fix this typo. So we just think this through. So it depends how we want to search for authors, right? Like, I mean, what kind of metadata do we want to search on? If we want to search for title alone, I think we can have the book title, like index on book title in Postgres. And if we're just searching by title, we can probably just get it from Postgres. But if we want to search by metadata, we can use Elasticsearch for that.
And what do you think the trade-offs are there on timing-wise of one over the other? Like, why the split?
So I'm thinking anything we want to do that's like fuzzy, we use Elasticsearch for, because it's going to be quicker. And I guess, like now that you mentioned that, we can have fuzzy searches in Postgres as well. Like people might want to fuzzy search the title. So it might be the case where we do titles in Elasticsearch as well, and maybe we use like the ISBN, and I think that's the correct name for it. But if it's something like ISBN where you have like exact data, then we search for it in Postgres.
Yeah, that feels a little more reasonable because I can imagine, right, like if a customer doesn't exactly write the title perfectly, which is very likely if you think of the use cases when people are searching for stuff, having that fuzzy match can be really helpful.
Yeah, that makes sense. All right, so I guess we could go deeper into like how we want to design the database, which this is the question, like, do we want the primary key to be the title or the ISBN? I think either ISBN or like some kind of book ID would be ideal here because they could probably have multiple titles. So I think I would design this like where we have like book ID as like the primary key, and then we have like the title, and this book ID could be the ISBN as well. If we decide to use that, we would just have like the title, the description, maybe like some kind of summary about the book, the author. We could basically have all of the metadata, so like the publisher. And then if we consider like these publishers and authors, like they can have their own table as well. So we can have like an authors table where we have like the author ID. So this would be an author ID, which we can join on and get like the author metadata. So that would be like the first name, last name, and all of that. Is there anything you want to go deeper in on the database design?
No, I think this is good.
All right, so kind of at this point, I want to think through like some failure scenarios, like where can this actually break? So I think one path would probably be the availability of Postgres and Elasticsearch. And we have like pretty high read throughput or like load, like a read path that's very like load bearing, right? So I think if we have like a big traffic spike, yeah, I would say if we have like a big traffic spike, we could get into scaling the database and like scaling, like setting up scaling rules. I don't really think it's like a super interesting conversation. Is there like a particular area you think we should go into?
Yeah, maybe not scaling. I mean, I agree it's not as interesting. But, you know, there are times when high traffic may be high traffic, but it's very similar traffic, right? So if you think of a scenario when a very popular book comes out, you might be getting a lot of traffic, but you're getting a lot of traffic for the same thing.
Okay, yeah, that's a good point.
So what would that look like?
Yeah, so say like we have a popular artist, we have some kind of like hotkeying issue. One way you can mitigate that is with Redis. So we could just put popular artist in Redis.
And what would the benefit be to that?
So if we have like, say it's like the new Harry Potter book, all of these lookups are not going to be actually hitting the actual database. I mean, we could do more than just like title queries. Like we could just keep our query name and then return the result. So this would be like title, author, essentially like whatever the query ends up being. And we could put this in front of I put this in front of Postgres. but it's not necessarily always going to hit Postgres. I would say the only situation where we would have a hotkey is if they're searching by ISBN, because if they're searching by like title and whatnot, it's going to be hitting Elasticsearch. So we can add the same cache to Elasticsearch, but Elasticsearch is already like in memory and pretty fast. So I'm not really sure how much advantage we would be getting, but we still do save like a lot of our. We won't be protecting Elasticsearch from like a hotkeying issue, but we will still be protecting it from like the very high repeated writes.
Right. And what are your thoughts on how you manage that cache, about when you invalidate it, maybe you refresh it?
So this is pretty static information. Like we don't expect this information to change often, so we can do like a 30-minute eviction, or we can even do longer. Like it depends how many unique searches we're getting, like how much we want to evict. So like we could do like as it gets to the end of memory and it hasn't been accessed in a while, we can evict it, or we could just do like a standard like 30-minute eviction.
And what do you think think of this scenario of like it being a bookstore. So sometimes we're adding new books, maybe we're running out of inventory, right? Like this is also sort of attached to our inventory levels. And especially if we're talking about, let's say, the same scenario of like a very popular book, like a Harry Potter book, what might those scenarios look like in that cache?
So you're saying like we're actually checking out books?
Yeah, like it's not just, we're adding or we're removing books. Like this is also around our inventory. So there may be
okay, I see. So you're saying like
where
we're showing how many books we have available. So you're saying like if we cache it for too long, we could be showing inaccurate information.
Exactly. So how do you keep that contract of what is a contract that you expect to be able to fulfill, of like how accurate that information needs to be?
It's a good question. So I guess there's two situations, right? It's like one is out of stock. We can probably cache it longer if it's out of stock, unless we expect it to come back into stock. But if it's in stock, we probably want to do a shorter cache, like say 10 seconds or maybe a minute.
Yeah, sounds good. So looking at this, I mean, what else do you think we need to think about?
It's a good question. So I guess it's the situation like it's not going to be users adding books. It's going to be more of like an admin user. We can go into like authentication and stuff as well. I wouldn't say it's super interesting, but we can do like a JWT where we have like claims and we're checking roles, making sure it's like an admin user who's actually adding this book. So like our middleware would be like is admin before they can actually access this add book route. I would say that there's probably like reservation semantics, like does somebody have this book reserved? It really depends if we want a system to support that. We could talk about like observability as well. So like one thing we probably want to track is like the Redis. So like what is our cache hit percentage? What is our end-to-end latency on the whole system? What is our query time on the database? We can set up alerting rules if any of this happens. We could also set up like scaling rules. So like imagine this is Dockerized, and we could scale it, like put it on like EC2 and then scale it as needed. So say this is probably like a pretty minimal application. I would say if we're just reading books, maybe our bottleneck is the CPU. So we could scale like as we get to like 80% CPU usage on this service, maybe we preemptively scale it, keeping in mind there's like scaling delay when we pay a price to scale.
Yeah, this all looks great. So maybe let's shift over and look a little bit at the API design.
Okay. So we want to get the book. Well, let's do the search book because I think it's more interesting is how we're going to do the search. And I guess the question for you is like, does a user need to be logged in to search?
Well, what would you expect? If you go to somewhere like Barnes & Noble, do you expect to have to log into an account to be able to search for what they have in stock?
It's a good question. I'm trying to think like what Amazon does. I'm pretty sure you can search without having an account. So maybe we want to do no authentication on the search path, which is something we need to consider can be like an abuse point. So we still need to rate limit by like IP address, since we don't necessarily have like a JWT token. So this website is frozen for some reason. Can you still hear me? Okay.
Yeah.
Give me 1 second.
Yeah, no worries.
What happens if I refresh the page?
I think it just brings you back in. You should be fine.
Okay, I think I'm good. So yeah, what I was saying was rate limiting. So we need to rate limit this slightly differently, probably like on the IP address to prevent abuse. IP address has its trade-offs, like it's not always going to be a good mechanism to rate limit on, but I think for the sake of this discussion, it's probably good enough. I would say the way we want to do search is we want to have some kind of endpoint. So like books/search, and I think we passed the search parameters with query parameters, and that's going to be easiest for caching. So we could just do query would be like the book title, and then we can have like author as like an optional thing. Maybe even we can do whatever we want, so like the ISBN or whatever we support searching by. We can even search by description. And this would be a GET request. And then we could go into a more authenticated path.
Yeah.
So we can have a post books, so books/upload, and this can take like the author. So this will just basically take all the information we're going to be writing into the database. The book ID. If it's not the SB in here, we probably want to do like a UID for this. We wouldn't generate this on the client. We would generate this in the add book service. So I'll just leave this off. We want this to be JWT authenticated, so only users with the role in the JWT token of like admin or like book owner or whatever we decide to call the role can upload books. And then the question is like, do we want to support images on these books? Because I think in an application like this,
Probably.
You would want to upload like the book image.
Yeah.
In that case, we need to introduce like a object storage here. We can use something like S3 for the images. And when we do add book, we can get a pre-signed URL, which gets sent back to the client, and that lets them upload the image directly to S3 using the pre-signed URL. And S3 is going to give us back a ID for that image, which we can store that ID in the metadata database. So like our book would have S3 image ID. And I think there's probably a little bit more to get into with that, is like how big do we want these files to be, and things like that. I would say we can like do limiting on the file size. Maybe we only allow like 50 or like maybe a gigabyte file for the most part. And then we could create thumbnails or something for the actual website and like compress it from there. That kind of adds a little bit of complexity to our system though.
Well, complexity that is potentially useful in terms of the use case for the user we're building for, right?
Yeah, I would say it's useful, and we could go into it if you want.
Yeah, let's do it.
Okay. So I would say once we upload, let me just move these out of the way. So once we upload this, we want to place the image on a queue. And this could be something like Kafka, where we have events. And these events are going to some kind of worker pool. And essentially what these workers are doing is like running the computation required to get these into different sizes and compressing it. So these would be like worker pool. And we can use Kafka consumer groups for this, where we're sending certain images to certain workers. So we can have like compression and resizing, which is like, maybe I'll write that somewhere else. Which is going to ultimately end up sending these back to S3, but we can bucket them, so we can have like, this would probably be like the same S3 instance, but imagine we have buckets for each one. So like the small bucket, medium, for each thumbnail. And we just send them to this bucket. And then we get the ID, and we can send it to the database, which changes our schema slightly, where we have like a small, medium, a large ID. I would say as well, like it's important to note, like we need to scale these workers based on the back pressure and like all latency requirements. So if we have like a SLA of like 5 seconds, when you upload a book, we want it to be seen. We need to scale these workers. I would say like this probably is not going to be an issue that we run into, because we're not going to have a lot of writes. So I think in most cases, like yes, this will be a synchronous path, but these workers will be scaled down most of the time. Maybe if there's some kind of like bulk book upload, like we just acquired another bookstore and we want to add all of the bookstore inventory at once, then we would have some kind of burst traffic, but I don't foresee it being something that we need to over design around, so to say. I would say maybe it's worth talking about this Kafka schema. So we want to have exactly once in this situation. So we can have like an idempotency key of like the book ID. And then we can have like the raw image. And this would be the S3 path. Then when these workers get it, they can download it, do the transformations, and then put it back into S3. And we're still preserving like the original image if we ever need it at some point.
Yeah, and you talked a little bit about, or you mentioned the SLA. Do you think this is something that needs to happen quickly, or is this something that can sort of happen offline?
It depends how quickly we expect the user to see the book. I would say we want it to happen relatively quickly, within the magnitude of like a minute or so. Not including network time, so the time that it actually takes to get into S3. But from the time it's in S3 to the time that we make it available on the website, I would say maybe 1 minute is a good SLA for that.
Yeah. Might even if it's longer than that, right? Like if we think of where our priorities are, if we're adding a new book, does it need to be at 8:58 versus 9 a.m.? Like maybe not, right? So there we have a little bit of flexibility on the timing of that. We may even want to batch a lot of this when we don't expect a lot of people to be looking at information on our bookstore if we have certain spikes in usage, right?
Yeah, it's a good point. We could do this as a batch as well. Makes sense.
Cool. So one tangent we can take here, sometimes at the 30-minute mark, it kind of depends where your experience is for the design, because a lot of design problems now are starting to incorporate some aspect of AI into them. And so kind of at the halfway point, I like to ask, like, is that something you want us to pivot and look at for this, or is that not really something that either your experience or your what you're practicing aligns to?
Yeah, I'm okay with that. When you say AI, do you mean like how can we incorporate AI into the system?
Yeah, like now what if the bookstore owner is like, hey, this is all well and good, right? But like I've heard there's now these new fancy AI systems, like a chat system I can use to actually help users find books or surface new books for me for the users. And they just come to you and they're like, you know, AI this design for me in a way that's actually like useful.
Okay.
What are the questions you ask, and what do you start trying to figure out where or what parts of the system may actually benefit from having some of that?
So there's probably two paths we can take to the AI question. One is like, do we want to use generative AI, where you just type to an agent and it finds a book for you? I think to do that, we can probably create like an MCP server, and then have the agent like reinforcement trained on some of these books. I think probably a better approach would be to have like a vector database, and we store description embeddings, and then we can have the AI do like a semantic embedded search and see like whatever is closest to your query. And then it's not really like, we don't really need generative AI for that, but we can have generative AI in the system like telling the user like, oh, I found these books and I think you might like them.
Yeah, so let's dig then into like the vector, the second option with the vector database and the search. What would that look like?
So we need to again have some kind of pipeline. And this could be a batch pipeline. This time it doesn't need to be something that happens in real time. But essentially we have some kind of ETL job that pulls these descriptions out and embeds them. So if you go to like a third-party embedding API, like OpenAI embedding, and they also have batch embedding, which is like drastically cheaper. So OpenAI embedding, and then we send it to them, and then at some point they send it back to us. This could be like through a webhook. So say we have like a webhook service. So when they're done with the embeddings, I've never actually done this, but I'm assuming that's how it works. When they're done with the embeddings, somehow they call back to our system. There's a question is like, what if OpenAI is down? We can have like a circuit breaker or something like retrying request, and we could do like a circuit breaker that slowly opens and tests if they're back up. Since this is not real time, there's no need for like a dead letter queue or anything like that, because we can just hold off on sending a request. So they send us back a webhook and we could send this into a vector DB. And I'm actually not too familiar with like the different types of vector DBs and tradeoffs. I think a popular one is Carper's DB. I might be wrong on that, but I would say some kind of vector DB, which lets us do search. And actually, I think Elasticsearch supports vector searches, so we might not even need to search this DB directly. Like we can in turn load this data into Elasticsearch and let it do the vector search, if that makes sense.
Yeah, that makes sense. And how do you imagine kind of a fallback scenario? So you talked about like what if OpenAI is down? Do you think we want to take down our entire Bookstore API in that case because our backend is down, or do you think there's potentially a hybrid solution that lets us potentially still be able to pass those results back?
So in that situation, these books just won't be searchable by vector until they get embedded. So say this happens at nightly, like a nightly ETL job that will extract them, prepare them for embedding, send them to OpenAI, then put them into our system. I would say, like, if OpenAI is down, our system's not going to be down. There's no risk of that.
And is there a way to work around that?
I wouldn't say there's maybe I don't understand the exact risk that you're talking about. Like you're saying if the embedding API is down.
Yeah, or if like our vector database goes down, right? So we're adding this like kind of AI piece by doing the vector embeddings and the search and then potentially routing that back. But we had a working system before we decided to add this. So do you imagine there's a way to have a version of both as a fallback?
Yeah, I mean, we can fall back to normal search. I think we can have like, well, we can fall back to the database directly, which would just give us slower search than Elasticsearch. So you're saying in the case that our vector DB is down, we would still have books loaded into Elasticsearch. So it's already like, I guess there was some redundancy built in because we're actually hitting Elasticsearch. If we want to fall back, we can fall back like embedded searches to the database directly and just like be acceptable that it might be like 1 to 2 second searches instead of like millisecond searches.
Yeah. Great. So this is one place. What else do you think?
I think probably the biggest risk is the webhook being down, because, well, I would say 2 things. If our database is down and the webhook can't write, we have to do something with these messages. So I think we create a dead letter queue here, which would just hold the messages until our database is back up, because we're paying for these embeddings and we don't want to lose them. There's probably some mechanism on OpenAI side where we can have them replay these events. I would say probably the biggest risk is if our webhook is down, because it's in Redis data and it's just getting 500. In that case, OpenAI should stop. This is like a third-party provider, so there's not really much we can do. But I would assume if they're sending messages to a webhook, they would just stop sending them until we fix it, and then we could go back and re-enable the webhook. So that might send us some kind of like email notification being like, your webhook is down. Go back in the dashboard to enable it.
Yeah. Okay, so those are kind of our side scenarios with having these embeddings and having this hooked up to our Elasticsearch. Where else do you think we could hook up AI into the system?
Yeah, so let's do like a more generative AI, where we have a separate request path for agentic search. And we can have this agent call like an MCP server for our own application. And essentially what an MCP server is it's just a list of tool calls that the agent can do. Let's do MCP. So my understanding of MCP, it's like injecting tools into the agent's context. So when it calls this server, we're going to send back a list of tools that it can use, and then this agent's going to be able to call routes on the server. And I'm envisioning this, well, it's going to be kind of weird to diagram, but the agent will talk to this, and then this will again go through the load balancer to actually hit our application. So say we have like a tool called for reading books. Let's call this semantic search. So it could pass this tool could basically just say we want to pass let's do semantic true in this. So if semantic is true, then you can search by like whatever. And we could probably get into like the design of this a little bit better. But for now, I think this is fine. And we can even break semantic search into its own pack as well, because I can imagine it's a lot more intensive than doing just a normal read on the database. Well, maybe that's not a true statement, but we can go into that later. Yeah, so it calls this, then we can have the agentic search. So it would have to be powered by like a third party. So say we use like OpenAI for this or Anthropic. But we just call the OpenAI endpoint, and we can have like a system role and some kind of like system prompt for the agent. So it's like telling it that it's a bookstore agent and it's meant to help the user. I would say the question of streaming here comes into play. So if we want to stream back to the user, we need to do WebSockets. I think streaming is like the best experience for this. So we could break our WebSocket layer into a L4 load balancer, and essentially what an L4 load balancer does is it just forwards HTTP request, UDP, and so this is probably too complex for this diagram, but there's the question of scaling these. So essentially these agent servers become WebSocket servers who are doing multiple tasks. So let's talk about the L4 load balancer real quick. Is you have a L4 load balancer, since it's just forwarding UDP, they're not able to like read HTTP requests. So the question is like, how do we know how to route them? And we do this at the DNS level. So we have WebSocket.domain.name. So that's how we know to go to the L4 load balancer is we're on this domain, because we can't just do like /WebSockets since there's no way to parse the URL. So it goes to this WebSocket server. And the trade-off with using like an L4 load balancer is like we have to do authentication on the WebSocket server now. So I'm just going to rename this to WebSocket server because it kind of becomes like a WebSocket problem. The question is like, when we have all of these services scaled out, how do we know which server you're being routed to? Like say we have 10 users doing like a WebSocket connection with ChatGPT, for example. We can have like a registry. Well, there's two things we can do, right? We can do like a broadcast where we're just sending like each thing to each server looking for the connection, or we can have like a registry, Redis registry, where we store each user's WebSocket connection. So when we go to send the message back to them, like streaming it through, these WebSocket servers can look up like where that user lives on the registry and send it back. And there's a lot of complexity here. Like this becomes very complex very quickly. So for the sake of time, it's like any problem you want to dig in on, because I think there's also like the third party, like OpenAI can drop the stream and we have to reconnect the stream. I think there's a lot of edge cases in this.
Yeah, and we are at 46, so we are almost done. So instead of going into that, I kind of want to talk about the final. So we've talked about different pieces, right? We had like the initial design, and then we had the embedding addition. We had the other going through kind of semantic search, the MCP server, the agent. So now you have to go back to your client, and you're looking at this design, and you're trying to give them a sense of what is the best path for how they should be thinking about this design in terms of priorities and where you think it best fits for them. So in order of like how important the different pieces are, like where do you think they should invest most of their time up front first to build, and like what pieces can they maybe scale out to third-party providers?
I would say they definitely want to probably do embeddings first because, well, it's more of a product question. So I would just recommend them the trade-off is like if you want to get like an agentic experience where you have an agent who is maybe you do like some kind of reinforcement on OpenAI side and you take that path where the agent already knows like all of the books in your inventory and you're just training on that, and then you have it just do the search by title or whatnot. You can do that as well. I think it's going to be a lot more expensive, and every time you add a book to your inventory, you're going to have to like reinforce the agent more. But the other path is like I would say probably want to prioritize like doing the embeddings because that's going to let any user search by like normal text. So they're like, I want a love story about, say like a dragon or something like that, like a medieval love story. They can just search that, and you're getting like 98% of the user experience.
Yeah, that all sounds good. I'm actually going to stop us there because I think any other piece we dig into is just going to take a while looking at the different edge pieces.
So, yeah, in general, first on your end, did you have any questions about the problem or the different paths we went down?
No, I don't think so. I think the AI section added a lot of interesting complexity.
Awesome. So yeah, let me pull up my notes, and I can talk through some of it. In general, I think you did really well. Good start with the functional versus non-functional requirements. One piece here, and I mean, we talked through it, and I sort of, in the questions I was asking you, I got a sense that you knew, especially on the non-functional requirement side, but it's usually pretty common in system design to start talking about like daily active users, like, and actually writing them out as part of our non-functional requirements. Thinking about the scale of the books that we're going to be working with, the scale of how much data we plan on going back, and we talk about low latency, like, what does that mean? Are we talking milliseconds? Are we talking seconds? Are we talking, what our range is? So we were sort of going through it, just talking it through, but it's usually a lot easier if you sort of write those out from the beginning. And especially me not having to prompt you for them. I mean, half of them you sort of went there by yourself. Half of them we got through me just asking some follow-up questions. And that should be like very easy from the beginning, just like vocab and numbers that you can kind of spit out based on the scale of whatever problem we're working on. In terms of the actual design, again, I think you did really well. Kudos, especially like making sure to mention auth and observability without me having to ask you. Those are pieces that I think a lot of people miss. Like they know about them, but it's not like the particularly interesting part of a design, right? And so really good job talking about those up front. I think there was a difference in the first half and the second half of the design of like how much you were driving edge cases versus asking me kind of direction. And so I I think in the first half when it was kind of just a simple, like, let's design this backend API, which granted, yes, it's not that interesting, but I expected you to drive a little more of the cases of like, you know, are we going to focus on search? Are we going to focus on the database next? Are we going to focus on the API? Like checking in and seeing, making sure like you're on track is great, but especially at a senior level design, like there's usually a lot less interaction from me as the interviewer, aside from just like, if you're going down a path I don't want you to, I might refocus you somewhere else. But I kind of assume you can drive a lot of that design without me having to kind of like guide you in the different directions. But that was completely different for the second half of the design. When we started talking about the AI piece, I feel like in there you were definitely driving a lot more of the like, okay, here's the scenario, here are the edge cases, here are the workflows, here are the things we need to think about for each of the pieces. And so, again, I don't know if maybe that's just because that problem's a lot more interesting, because there's just a lot more kind of complexity you can add there, a lot more like different things that you can talk about, but it'd just be sort of like a warning to make sure you're doing that sort of in all parts of the design, if that makes sense.
Yeah, that makes sense. Yeah, I did kind of panic because I was like, it's like a very simple design that we have, so I'm like, where can this fill? I had to like stop and think.
Yeah. Which is totally fine. I think I intentionally started out simple because people can focus in a lot of different areas. So especially if you get that feeling that you're like, maybe it's too simple, you already have the pieces, right? Like you were looking at the database, you knew we had to look at the API, you knew we had to look at the cache, like just start working through the pieces. Usually, especially at a senior level design, there's going to be a point in the design where, you know, it may not shift to AI, which is the path I kind of took, but usually they want you to get like a simple thing laid out, and then they'll add an edge case or a new requirement or a new kind of like sub area, and kind of go from there. So I think you handled it really well, but just kind of be ready for it on that end. And let me see if there's anything else I missed. You have really good knowledge of all the technology. I think that's really good. You know, we were talking about Kafka, we were talking about Elasticsearch, we were talking about caching, different types of storage. I think that's great. Make sure just sometimes to explain your rationale for why you're choosing certain pieces, like, you know, what is the usefulness of having something like Elasticsearch? Why do we want and why do we think it's good to have like an event-driven message worker pool situation? Like, even if it's all of like 30 seconds, because it's like, well, this is kind of the standard, but the reason it's the standard is because, you know, in scenarios like this, it's really good for batching, or it's really good to like distribute the work between a lot of workers so you're not kind of hanging if something goes down, right? So even just a really simple, like, I'm choosing this thing and this is why, keeps me from then having to ask you the follow-up or wondering, like, does he actually know why we should do this, or is this just like the path he chose and I have no kind of insight into kind of your design thought process?
Okay.
But yeah, other than that, I think you did great. Do you have any other questions, any other follow-ups you might want?
Yeah, no, I don't think so. I think, yeah, no, I don't think so.
Awesome. Well, we can go ahead and wrap there then. I know we're 4 minutes early, but I'll go ahead and write up my feedback for you as well. And yeah,
okay,
great job.
cool. Thank you.